Now we look at an example 2. Determine the maximum points for fx is equal to x plus 2 multiplied with x minus 1 squared. So this fx is actually a continuation of example in part 1 analysis of function. So when we have fx x plus 1 multiplied with x minus 1 squared, by using the product rule, we get the f prime x as 3x minus 1 x plus 1. Okay, we get also the critical points. If we make it f prime x equal to 0, so we get x is equal to 1, x is equal to negative 1. So this is the critical point. When x is equal to 1, if we substitute x is equal to 1 in f, we get 0. So f1 is 0. At x is equal to negative 1, we substitute in fx, so we get f negative 1 is equal to 4. So therefore, the critical points are 1, 0, and negative 1, 4. So this is the sign table analysis for f prime. Alright, so if you look at here, this is the critical points. We have negative 1 and 1. And we get the plus minus table for x minus 1 and x plus 1. And for f prime x, we get for x less than negative 1, we get it is positive. Between negative 1 and 1, we get positive. X greater than 1, we get positive. So if we draw the line, okay, for x, f prime x positive, it is a slope positive or increasing function. F prime x negative, it is slope negative, decreasing function. And if it f prime x positive, for x greater than 1, it is increasing function or or positive slope. Alright, so if you look at here, if we join these two lines here, okay, on the left and right of x is equal to negative 1, we can see that f is maximum when x is equal to negative 1. So that is why this point is the maximum relative point, relative maximum point. Alright, similarly here, if we join these two lines, on the right of x equal to 1 and on the left x is equal to 9, both lines we join together. So you can see that f is minimum at x is equal to 1. Right? So therefore, we get the relative minimum point is 1, 0. This is from here, 1, 0. And the relative maximum point is negative 1, 4. Now we look at the definition of, the concavity. So this is the shape of concave arc. It can host water actually. So a function is concave arc when it bends up. It bends up, we get it concave arc. Alright, so concave arc function, if you can see here, we have the decreased part and increased part also for a concave arc function. This is a concave down function. It actually spills water. You can see also for a concave down, we have part, the increasing part, and this is the decreasing part. Okay, this is the concavity test. Let f be a function whose second derivative exists on an interval I. If f double prime x greater than 0 for all x in I, then f is concave arc on I. If f double prime x less than 0 for all x in I, then f is concave down on I. Okay, this is a procedure to find the concavity. First, we need to find f prime x. Second, we find f double prime x. And after that, we are going to build the table of sign indices for f double prime x. Right? If we recall back for decreasing and increasing interval, we do the f prime x table sign. But for concavity, we draw the sign analysis for f double prime. And after that, we test the concavity based on the table f double prime x. Okay, what is inflection point? Inflection point is a point on the graph where the concavity changes from up to down or down to up. Or we can also say that it is a point where it switches between concavity. So if you look at this graph, alright, so you can see that x less than 0, it concave down. And x greater than 0, it concave up. Alright, so that is why point x is equal to 0, it is an inflection point. Right, 0 to x0, y2, we get the point as inflection point. The length of 0, it is concave down. The greater than 0, x greater than 0, it is concave up. Okay, now we look at the third example, where we want to find the intervals on which fx is concave up and concave down, and we also want to determine the inflection point if there exists the inflection point. The function is given as x cubic minus 6x squared plus 9x plus 1. So the first step, we need to find the f prime x. So this is the f prime x. Then we find the f double prime x. Okay, if we factor this one, we factor it into linear factorization. So we get 6x minus 2. So from here, we get important points is x is equal to 2 from the factorization of f double prime x. So we draw the sign basis for f double prime x. Look at here for f double prime x. So if you look at here from the f double prime x, we get the point x is equal to 2. So that is why we get x is equal to 2. We have area x less than 2 and x greater than 2. And if you look at here from f double prime x, we have the function x minus 2. So we put here x minus 2. We test the test the sign here. X less than 2, say we pick up 1. 1 minus 2 is negative, so we get negative. X greater than 2, we choose, for example, 3. 3 minus 2 is 1, so it is positive. So since f double prime is only affected by factor x minus 2, so we choose this one, or we represent x minus 2 as f double prime x. So f double prime x is actually negative and positive here. Okay, similar with x minus 2. Alright, so we draw the concavity here. So f double prime x negative, concave down. So that's why we draw the concave down here. And for x greater than 2, f double prime x is positive, so it is concave up. So we can see that the concavity changes at x is equal to 2, thus the inflection point occur at x is equal to 2. So if you look at here, at x is equal to 2, on the left we get concave down, on the right concave up. So it changes from concave down to concave up. So therefore, the inflection point occur at x is equal to 2. So what is the inflection point actually? Alright, so since it occur at x is equal to 2, so we substitute x is equal to in the function of f. So get f2 is equal to 3. So therefore, the inflection point is 2, 3. Okay, this is the example. You can try this example. Okay, we have two parts here. First, we want to find the interval of which f is increasing and decreasing. And after that, we are going to determine the maximum point, if any. And we also want to find the interval of which f is concave up and concave down. And after that, determine the inflection points, if any. Okay, you can try this example at home. Okay, I'll see you in the next class. That's all for today.